Welcome. In this video, we are going to discuss conditional distributions. Okay. This is a case where we deal with two random variables. Here we are considering two discrete random variables which has some joint probability mass function f of xy. Okay. Out of which we fix one value for one of the random variable and we try to look for the conditional probability mass function of the other variable. Okay, so this is denoted as f of x vertical bar y, that is x given y. It is read as x given y is probability of x equals y given y equals y, which means assuming this y equals y, this event has happened. Okay, when this has happened, what is the probability that this is happening? It is like providing math teacher has come to the college or school, and what is the probability of cancelling the class? Okay, so if the faculty has not come to school at all, then we don't have to talk about the probability of cancelling the class. Okay, this has happened. The faculty math teacher has come to the college or school. Okay, they have come. Under that condition, what is the probability that we are cancelling the class? So these kind of situation, this is one example that I have given you. These kind of situation, provided something has happened already, what is the probability of happening of the other event? This is denoted as probability of x equals x and y equals y upon probability of y equals y. The numerator part is the joint PMF. Okay, and the denominator part is the marginal PMF. Okay, in a similar way you can uh, define the conditional PMF of y given x, right? We move to some example. Here we are given with some joint PMF of two variables. P of x y is k times of 2x plus y, and x is taking these three values 0, 1 and 2, and y is taking 1, 2, 3. We are asked to find out the marginal and conditional probability distributions, and in the second part we are asked to find out the probability distribution function of other random variables. So this x plus y, I will come to this x plus y when in the due course. Okay, now from this we are writing the probability mass function for these things. Okay, so we'll just list the possible values of x and possible values of y. Okay, substituting this in the given p of xy, we calculate the inner values. So for each possibility of x, we calculate these three values, and similarly for y. Okay, and this is the total, be it column wise or the row wise, this is the total. So what we get here is our summation under x, summation under y. F of xy is 72k, which is 1. Therefore k should be 1 upon 72. Okay, now we are asked to find out the marginal probability. First of all, we will have to find out the marginal probability distributions. Okay, so this is the fx of x values for different values of x, and this is fy of y for different values of y. So this shall be listed like this. Here your x is going to take only three possible values, we calculate it, and similarly y is going to take three possible values, we just calculated it. All you have to do is that your x is taking 0, 1 and 2. So your fx of x is 18 upon k, that is 18 upon 72, and this is 24 upon 72, and this is 30 upon 72. If you simplify it, you will get the values over here. In a similar way, your y is taking the values 1, 2, 3, and your fy of y is what? 15 upon 72, 24 upon 72, and 33 upon 72, and if you simplify it, you will get this values. Now that we are asked to find out the conditional probability distributions. So P of X given Y. They have simply said that conditional, which means we need to find out probability of X given Y as well as probability of Y given X. Both the things we are going to calculate. Okay. So for which what do we need? We need the joint PMF and the marginal PMF. We know these values. Okay. Here what is fixed? Y is fixed. Okay. And here if you see we are fixing 1, in that case what is going to happen? We are fixing 2, and in this case what is going to happen? Now that once you fix 1, that is you have fixed y equals 1, come back to this thing, y equals 1, only these things. Okay, if you want to rewrite it, you will have 3 upon 72. Everywhere you can just substitute the value of k. So 3 upon 72, 5 upon 72 and 7 upon 72, and that simplifies to this. Okay, and similarly for y equals to, here you just have to substitute the things. Okay, and calculate it accordingly. And coming to this, okay, y given x, here what is the thing? You are fixing the value of x. So you are fixing the value of x and you are going to vary the value of y. Okay, and accordingly you will have to calculate it, right? Okay, now we are coming to this probability distribution function of the random variable x plus y. So now that uh, you have two distinct random variables, now we are defining some other random variable with the help of this thing. So now we are basically performing the transformation of random variables, right? Okay, now if you look at this thing, your x plus y, x is taking these three possibilities and y is taking these three possibilities. So at the most your u can take how many values? So it is starting from 0 plus 1. It is 1. Okay. 0 plus 2, 2. 0 plus 3, 3. Okay. Then 1 plus 1, 2, which is already counted. And 1 plus 2, which is 3, which is counted. And 1 plus 3 is 4. In a similar way, 2 plus 1 is 3 counted. 2 plus 2 is 4, which is counted. And 2 plus 3 is 5. Okay, in what are the cases we have these possible values, that we will have to list. So when x is 0 and y is 1, we get this. Okay, here x is 0 and y is 2 and x is 1 and y is 1. These two are the possible cases. Okay, for 3 it is 0 and 3 and 1 and 2 and 2 and 1, isn't it? For 4 it is 1 and 3, 2 and 2. Okay, for 5 it is simply 2 and 3. Now you come here, 0 1, this is the only possibility, that is 3k, that is 3 upon 72. Okay, and this is the probability that u is taking the value u. Okay, now 0 and 2 and 1 and 1, so it is 11k, so 11 upon 72. Okay, now 0 and 3, 1 and 2 and 2 and 1. So these three possibilities are there. So which sums to 24k, 24 upon 72. And for the other case, it is 1 and 3 and 2 and 2. So it is 21 upon k. So 21 upon 72. Okay. This is the only possibility for 5k. It is 13 upon 72. So this is what we need to calculate. Okay. After simplifying, we get this one. Right. Thank you.